Hello dear students, so in today's video we are going to discuss the very important naming reaction from aldehyde ketone topic, that is the aldol condensation reaction. Okay students, so first of all you see what is the meaning of aldol. Okay, so here aldol, what is the meaning? So here Al stand for, so this Al stand for aldehyde. Okay, so this is the functional group of aldehyde Al, and Ol stand for alcohol. Okay students, so now all of you clear what is the meaning of aldol? So Al stand for aldehyde and Ol stand for alcohol. So that means in this aldol condensation reaction, two functional groups are involved. One is the aldehyde and second one is the alcohol. Okay, so now clear everybody. And next, what is mean by condensation? So actually condensation is nothing but there is a removal of water molecule. So condensation is what? So there will be the remove of H2O, means water. Okay, so that is a condensation. Now clear students, so all of you clear what is the aldol condensation? So Al stand for aldehyde, Ol stand for alcohol, and here condensation is nothing but there is a removal of water molecule. Now we'll discuss what is the condition for this reaction. So aldehydes or ketones which carry the at least one alpha hydrogen atom, so such aldehydes and ketone undergoes this reaction. Okay, so let you see what are the alpha hydrogen atom. Okay, so then we'll see this reaction. Alpha hydrogen atom, we'll see some example here. Suppose I am taken one example. So we'll take the one example of acetaldehyde, CH3 C double bond OH. So this is your acetaldehyde molecule. So let you see, this is your carbonyl group. So next to the carbonyl group you can see is alpha carbon. Get it? And if next carbon is there, we can see the beta, gamma, like this. So this is your carbonyl group, C double bond OH, that is a functional group of aldehyde. Now clear? And next to this is alpha carbon, and that means it have the 3 alpha hydrogen atom. Means this acetaldehyde undergoes this reaction. Let us see students, if you take the formaldehyde, H C double bond OH, is it formaldehyde? Yes. So this is your carbonyl group. So there is a no next carbon, means here is a absent of alpha hydrogen atom. So in case of the benzaldehyde also there is absence of alpha hydrogen atom. So what is the condition for this reaction? Aldehyde or ketone having at least one alpha hydrogen atom. Only such aldehyde or ketone undergoes this reaction. If you take the acetone, CH3 C double bond O CH3, is there alpha hydrogen atom? Yes. So this is your carbonyl group, and next to the carbonyl group this is alpha carbon, here also alpha carbon, and 3 hydrogens are there. That means there is alpha hydrogen atom is present in case of the acetone also. Okay, if you take any aldehyde group, any ketone groups, there will be the alpha hydrogen atom is present. Now clear students? So we'll see the example now. So here we'll take on the acetaldehyde. Okay, so acetaldehyde undergoes this aldol condensation reaction. Acetaldehyde. Okay, so what is the IUPAC name of acetaldehyde? So how many carbon? 2 carbons, means it is a ethanol. Okay, Al means aldehyde group is there. So here we will take on the 2 molecule of acetaldehyde, means ethanol, CH3 C double bond OH, CH3 C double bond OH. Okay, this is also acetaldehyde. Now clear? Here we will take on the 2 molecule of acetaldehyde, and this acetaldehyde we can react with dilute NaOH. So here we will take the NaOH, sodium hydroxide. So this is a diluted form, means NaOH we can dissolve in water. Okay, so when we will carry this reaction, let you see what happened in this reaction. Okay, so very simple. So actually this is a, we can say is a reversible reaction, reversible arrow you can show, and we'll show the below. Okay. So what happened in this aldol condensation? So we can take the 2 acetaldehyde molecule, means aldehyde or ketone which having at least one alpha hydrogen atom, so that undergoes aldol condensation reaction. Okay, so here we can take the 2 acetaldehyde molecule that will react with the dilute NaOH, and it can form the aldol. So now we'll see how aldol will form. So what happened in this reaction? So from the second molecule of acetaldehyde, from the CH3, one hydrogen is removed, and that hydrogen going to be attached to this oxygen. And here CH2, that CH2 will join to this carbonyl carbon. Now this double bond will shift. Okay, so very simple. From this second molecule of acetaldehyde, one hydrogen join to this oxygen, and this whole CH2 C double bond OH group join to this carbon. So let you see how reaction will carry. So I will show here CH3. Then this carbon. So now when CH2 will join here, so this oxygen carry now single bond. Okay, now this hydrogen join to this oxygen. Okay, so this CH as it is, and now from this CH3 hydrogen already attached to the oxygen. So now what left here? CH2. So whole group you can write here CH2, then C double bond O H. So this is a aldol. What is the name of this? Aldol. Why we can see is aldol? Because whatever product here will get, it both contain the alcohol group OH means OL, and aldehyde group, that is a AL. Get it, students? So whatever product we here will get, that contain the both functional group alcohol as well as aldehyde. So that's why you can see is what? Aldol. So what is the IUPAC name? Let me give the numbering 1, 2, 3, 4. Total 4 carbons means it is a butane. So in that butane functional group is aldehyde and hydroxy group. We can see is what? On third carbon OH group is there 3 hydroxy butanol. AL, yes, that is aldehyde, 3 hydroxy butanol. Get it, students? So this is aldol will get. Now we will see what condensation takes place. So if you take this aldol and if you heat this, okay, after heating, so we have to heat this, very simple. After heating, what happen? So it can loses the water molecule. How water molecule will remove? So this OH, obviously this OH will remove, and from this CH2 one hydrogen is removed. From this CH2 one hydrogen, this hydrogen and this OH, H2O will remove. Okay, so simply what get? So now OH is removed and one hydrogen is removed. What remain here? CH. Now here also CH. Obviously double bond will come. So what is the product here? CH3 CH double bond CH. Now C double bond O, this H, this group as it is. So see here, this CH3 I am written as it is. Now this CH, because this OH and this H is removed, H2 will remove. So we can write here plus H2O. Now clear, students? Water is removed and this CH, now here one hydrogen is removed, means here also CH double bond will come, C double bond OH. So this is what? Crotonaldehyde. Crotonaldehydes. Now clear, students? So crotonaldehyde will get by removing the water molecule. That means it undergoes condensation. So now all of you clear, this is aldol condensation reaction. So now we'll discuss the mechanism of this reaction. Okay, students, so before that you just take a screenshot. I will explain the mechanism. So the mechanism in all the 3 steps we'll explain one by one. So before that you just take a screenshot and write down these notes. Okay, students, see here the mechanism. So mechanism of this reaction in all the 3 steps. Okay, so first step, that is a formation of carbanion. So first step is what? Formation of carbanion. So already in aldol condensation reaction we will take on the 2 acetaldehyde molecule. We will take the first molecule here. So I will write here acetaldehyde CH3 C double bond O H. So this is your first molecule of acetaldehyde. Now clear, students? So in step first we can use first molecule. We have taken the 2 molecules. So first molecule, this reacts with NaOH, means from that nucleophile is OH minus from NaOH. So this OH minus can abstract the one hydrogen. They can abstract the one proton from this first molecule of acetaldehyde. From this CH3 one hydrogen they can abstract and it can form the water molecule like this. So if from CH3 one hydrogen is abstracted by this OH, it can convert into the H2O. So simply we'll get here carbanion CH2. Now minus charge will come, C double bond O H plus H2O. Now clear, students? So this is your carbanion. Step first, there is a formation of carbanion. Okay. Now step second is very easy. So step 2. So in step 2, what you have to do? You can take the second molecule of acetaldehyde, and that second molecule of acetaldehyde reacts with this carbanion. That means this carbanion will attack on carbonyl carbon of second molecule of acetaldehyde. I will take here second molecule of acetaldehyde CH3 C double bond O H. Now get it? So this is your second molecule of acetaldehyde. We'll take in here, and so this carbanion, whatever carbanion will get in step first, we can write here CH2 minus, then C double bond O H. So this is the carbanion will get in first step. Okay, now this carbanion will attack on carbonyl carbon of second molecule of this acetaldehyde. Carbonyl carbon means this carbon. So this CH2 group will attack here. Okay students, when this carbanion group will attack here, so obviously this double bond will shift and here we'll get a single bond. And what we'll get students here? Simply CH3. Now CO minus will get here and this CH as it is. Get it? When this CH2 will join, obviously this double bond will shift and this whole part will join here. CH2, then C double bond O, H. Now get it? So CH3 this. Now double bond already shifted, CH3 CH. Now this CH2, this whole part will join here, CH2 C double bond OH. So we'll get here intermediates. Okay, we can say is the intermediate. Okay, in between the product and reactant and product. So we can see is what? Intermediates. So now in step third, whatever intermediates we'll get, so it undergoes protonation, means we can add a hydrogen. So step third, that is a protonation. Okay students, protonation. Now all of you clear? Protonation. Intermediates will get here. We can take that intermediates here. Step third, CH3. Now here CH. Okay, then here O minus. Then CH2 and C double bond O H. So this is your intermediate. We'll get in second step intermediates. So here it undergoes protonation, means we can add a H plus ion. Okay, so when this H plus will attack here, so obviously now it convert into the OH. Simply what we'll get? So this CH3 as it is. Okay students, now this CH. Now hydrogen will join, means it convert into the OH and remaining part as it is, CH2 C double bond OH. So now you see here, this is your aldol. Get it? This is your aldol. So here aldehyde group is there, C double bond OH, and here OH alcoholic group is there, that is the OL, and this is the AL, means aldehyde group. So it is nothing but 3-hydroxybutanol. Okay, so again when this 3-hydroxybutanol we can heat. Okay, after heating it can loses the water molecule, and simply what we'll get? Will water, how will remove this OH and this H? H2 will remove, and simply here we'll get a crotonaldehyde. I will write here CH3 CH double bond CH. Okay, and this C double bond O H. So this is your crotonaldehyde. Simply. So already we discussed in that reaction. Now clear students, so this is a mechanism part. So once again I repeat. So the mechanism of aldol condensation reaction in all the three steps. Step first, there is a formation of carbanion. So what we can do? So already in reaction we are using the two acetaldehyde molecules. So first molecule reacts with NaOH. From NaOH, OH group is abstracted by the hydrogen from first molecule of acetaldehyde. So from the CH3 one hydrogen is removed and now it convert into the H2O, and what remain here? CH2 C double bond OH. CH2 C double bond OH. It is a carbanion and H2 will remove. So now in second step, whatever carbanion will get, that carbanion will attack on carbonyl carbon of second molecule of acetaldehyde. Here we will take on the second molecule of acetaldehyde, CH3 C double bond OH. So now this carbanion will attack here. So obviously when this will attack, this double bond will shift and we'll get this intermediate. Okay, and step third, that is a protonation. That means we can add the hydrogen ion H plus. So now this oxygen can abstract this hydrogen, it convert into OH, and simply here we'll get what? Aldol. So this is your aldol condensation reaction with mechanism. Okay guys, so if you like this video, please subscribe the channel and press the bell button. You get the daily updates regarding such a new videos. Okay guys, thank you so much. In next class we'll discuss about the another important naming reaction, that is the Cannizzaro reaction. Thank you so much.